ini akan mendeteksi setiap cacat yang ada. Hasil cacat ini bisa kita lihat dan kita analisa melihat dari signal-signal mulai dari sudut 90, 180 maupun mix. Di dalam software juga tersedia file untuk latihan, atau bisa kita sebut dengan demo file. Jadi dari sini kita bisa melihat dan juga digunakan sebagai acuan. Misalkan kita saat menggunakan probe ECT dengan tipe bobin probe, kita ingin mengetahui bagaimana sih tipe cacat pitting ataupun wall loss atau korosi yang sudah sangat besar, wall loss. Ini kita bisa lihat dari sini. Nanti juga akan muncul signal diferensial 90 maupun diferensial 180. Tidak hanya ECT, di sini juga bisa kita lihat iris, MFL maupun NFT. Kemudian kita juga bisa atur display dari tampilan software seperti berikut. Ada dari display, scan, dan tampilan analisa. Kita juga bisa atur jika memang usernya sudah terbiasa dengan tipe inspeksi lama atau RT-tag ya, atau entity data charge, kita bisa ganti tipe data display-nya menjadi entity data charge. Kemudian untuk multiview sendiri sudah optimal untuk interface-nya, jadi lebih mudah digunakan, analisanya juga lebih cepat, desain dan kontrolnya baru, shortcut juga baru. Berikut interface-nya, kita bisa lihat dari sini ada shortcut tombol yang mana kita bisa ganti dari ET channel, alarm, analog, dan lain-lain. Kemudian juga kursor pilihan dari signal atau saat kita fokus ke beberapa signal yang kita inginkan lebih friendly, lebih mudah digunakan dengan menggunakan mouse. Memang untuk penggunaan software lebih mudah dan lebih nyaman ketika kita menggunakan mouse. Kemudian juga bisa diklik untuk measurement dari signal. Kemudian untuk pengembangan kasar, kita bisa melihat jarak dari indikasi cacat menggunakan encoder. Kita bisa juga menggunakan encoder. Kemudian kita bisa menggunakan interpolasi menggunakan landmark. Kemudian landmark sendiri merupakan bagian struktur dari ECT yang menghasilkan signal dengan ECT secara umum. Kemudian seperti jump sheet dan jump end. Kemudian ada support. Bagian ini jump end. Jump support 2, dan seterusnya. Nah, kita bisa mengindikasi ketika ada kerusakan dalam satu panjang jobbing ini, kita bisa melihat indikasi dari cap supportnya. Nanti akan dijelaskan lebih detail oleh Pak Franco untuk penggunaan pembacaan signal dan softwarenya. Jadi secara garis besar memang acuan utama untuk mengetahui posisi cacat dalam satu tubing ini bisa kita lihat dari signal chop support. Walaupun dalam alat kita tidak menggunakan encoder atau pembacaan jarak ya. Dan di multiview kita memiliki kemampuan landmark. Untuk penggunaan landmark kita bisa gunakan ECT, RFT, NFT, dan NFL. Untuk iris sebenarnya kita untuk landmark kita memerlukan aktual encoder untuk memperoleh data posisi. Dan juga untuk software multiview dengan dongle MVAT USB kita juga dilengkapi dengan chip analisis untuk menampilkan cacat 3D pada Jupro seperti pada gambar. Ini adalah sebelum mulai penggunaan alat, kita pastikan bahwa kita menggunakan direktori berikut sebagai setup default jika ingin memudahkan penggunaan. Dari default ini kita bisa memanggil seperti demo list, demo report, dan juga setting. Jadi kita bisa lakukan pemanggilan setting, jadi akan lebih mempermudah penggunaan software. Dan dari software juga kita bisa melakukan indication recall yang dapat digunakan untuk merecall setting seperti ini. Nah, ini bentuk dari tampilan report. Dan ini juga tersedia untuk shortcut untuk navigasi dari indikasi, misalkan kita ingin pindah ke indikasi yang lain di sebelahnya. Mungkin itu untuk pengenalan fitur dan aplikasi dari software multiview 6.1 dan juga alat MS5800. Selanjutnya untuk training operasional alat dan juga software, waktu dan tempat saya serahkan ke Pak Franco. Pak Franco, screen and
Yes.
time is yours.
Okay. Yes, again, good morning, everyone. Thank you, Nursidi, for the introduction of the equipment. So a while ago, you just heard Nursidi on the overview of the MS5800. So now I'll be tackling more on the specific technique, which is the ECT. Okay. Beforehand, I would like to introduce myself. I'm Franco Pasqua. I'm the Olympus product specialist for conventional and advanced eddy current and UT. Okay, I've been working with Olympus for 2 years now. My previous job is mainly in aviation company. I used to work in Singapore Airlines, Rolls-Royce, PW, and CFM. Okay. Most of my, as what I mentioned earlier, most of my job is more on aviation companies. So it's my first time working with industrial. So hopefully I can share my knowledge, what I've been learning from Olympus for the couple of years. And if you have any questions, do let me know, or during the presentation, if you have, if you have any questions, just let me know, and then if not, then we can do it at the end of the presentation. Okay. Before anything else, again, is any one of you holding the MS5800 now?
For the device,
Yeah.
we will do unboxing and checking the tools for tomorrow
Oh, okay. Because uh,
because
uh, I
our
don't have the equipment now.
so
Yeah,
wait.
I thought it's we're going to use the customer's equipment.
Okay, wait. I will discuss with Pak Zulfikar first.
Yeah, yeah. So maybe I'll just present first my slides for ECT while Nursidi is discussing with the usage of the equipment. Yeah. Wait. Can anyone see my screen?
Yes, Pak.
Okay. So as I mentioned a while ago, this would be a specific training slides for ECT. Okay. So for today's topic, we will be discussing more on the characteristics of the ECT technique, and then the frequencies and channels used for this equipment, for this technique, sorry. Then we'll do setup and calibration. And after that, creating data files, acquisition, analysis, and reporting. Okay. So do take note that this creating data files, acquisition, analysis, and reporting, we will use the multi-view. Currently, I don't have the Tube Pro and I don't have the Carto. Okay. So we will do first a basic creating data on your multi-view. Okay. So what are the characteristics of ECT technique? Let me put down this. Okay, so it's suitable for non-ferrous tubes. Okay, so it uses multiple frequencies for better analysis and flow sizing. Okay, needs a good fill factor. So it's around 85 to 90% of the ID. All right. And probe centering is very important for uniform sensitivity and for reduced lift off signal. Okay. Do make sure that, we need to conform with this recommendation, so that if you don't have a good fill factor, the amplitude of defects will become lower, and at the same time, you will have a lot of uh, false indications. I mean, you will not be able to size the correct defect flow. All right. And then, of course, it's a fast technique. So you can have up to 2 meters per second pulling speed when using this ECT technique. Okay. So we'll go on with the frequencies or channels that is used in that are used in ECT technique. So first, you will have the absolute 90 channel, or A90. So this channel is used in detection of and analysis of larger defects. Okay, so used to check 90-degree separation between um, outside diameter groove of 20% and ID groove of 10%. Okay, so this would be a good representation of having a absolute 90 channel. So you'll see this below defect. This is the ID groove 10%, and then this would be your OD 20%. Okay, so you can see that there is a 90-degree of separation between the two defects. Okay, so that's why they call it an absolute 90 channel. Right. So how about on differential 90? Okay, so the differential 90 channel is used to detect and analyze of smaller defects. Okay, so you have your flat bottom holes on your calibration tube, so you'll need the differential 90 channel to analyze those flat bottom holes. Okay, next, how about the differential 180 channel? Okay, so this channel is used to analyze smaller defects due to greater separation of defects. Okay, so you'll just need to, it's like a differential 180 is the double of differential 90. Okay, so you can see here on differential 90, the separation between defects are quite narrow. So they are like, close to each other. Okay, but when you use a differential 90, there's a better separation between smaller defects. So this one is also good for the analysis of your defects, especially if there are small ones. Okay. Oops. So next would be the mixed channel. Okay, so this mixed channel is used to eliminate the tube support plate signal. So as mentioned by Nursidi a while ago, if you would see a heat exchanger or a condenser, okay, there always be a support between the tubes to make the tube steady on their location. So these supports are made up of most frequently is carbon steel or ferromagnetic. So it creates a indication when the probe pass by these support plates. So of course, if you don't eliminate this, it will show you like defect signal. So you need to eliminate this support plate signals by using the mixed channel. Okay. And
Pak
so
Franco,
yes,
can I
yes.
ask something? For the mixed channel, is the type of signal is always like in the picture in the display,
Uh,
always like that.
Sometimes no. Sometimes depends on the support that you're using. Okay. So typically it's something like this. Sometimes it's opening up like very big.
Oh,
So now you see it's quite narrow, and then there's a loop here.
yes.
There's a two loop here, right? So this one is signal for support. Sometimes the loop is quite big like this compared to a smaller one. This one, it's a defect because the loop is quite narrow. But if the loop is too big, then yeah, you can call that a support as well.
Okay.
And then if you will see the mix channel here, mix one, there's no indication.
So we can just focus on the mixed channel
Yes,
only.
yes. So if there's a defect under the support, you can see under mix channel here. You can see that there is an indication. Okay. So you
Okay.
can see here, on this presentation, you see that there's a D90 here, differential 90, and then mixed channel. So at differential 90, you see there's a signal, but when you go to a mixed channel, there's no signal at all. That means this is a support.
Okay. For the mixed channel, it always use differential 19 and differential 19 per 2.
Yeah, that's the
Always.
setup in the equipment. It's always
Okay.
using this.
Okay.
Okay. To continue. Okay, this is an additional channel that we usually do when we're using the Olympus calibration tube. Okay, if you would to use our Olympus calibration tube, you have three additional defects. Okay, so you have an additional of big hole, you have additional OD group of 40%, and then additional OD group of 60%. Okay, so usually we add another channel with the voltage depth curve. Okay, so this is an extension channel. If you would see here, so under A90 you will only see this one, 60% OD, right? But when you click down this arrow, you will have a V over D, okay, as an extension. So you will see, you will also see that it's also a 60-degree or any indication. So this is meant for, yeah, this additional channel is meant when you are using when you're using our calibration tube with extended defects, okay? If you don't have any extended defects, you're using only ASME standard calibration tube, no need to use this one. Anyway, I will be teaching you how to do this one later on in your equipment. Okay. So this is the setup that we will be using. Okay. So you have your equipment here, which is the MS5800. Okay. Before that, before opening your multi-view, you need a communicator or a software that communicates between the MS5800 and the multi-view, which is the boot P. Okay, so aside from installing your multi-view, you need to install also your boot P so that it will have a better communication between the two with the hardware and the software. Okay, and lastly, your the software that you're going to use while you're doing your tube inspection will be the multi-view. Okay, so this would be the probe and then the calibration tube that you will be using. Okay, so you have your bobbin probe, of course, your ECT. And then for your calibration tube, as I mentioned a while ago, if you're using our calibration tube, you have three additional defects here. You have your big hole. This is bigger compared to the hole on ASME standard. Okay, you have a hole also here, but this one is a bigger in diameter. Okay, and then you have your OD group of 40%, and then OD group of 60%. Okay, for ASME you only have one, which is the OD group 20% here. Okay, so any questions so far?
Apakah ada pertanyaan, Bapak-Bapak sekalian?
So if not, yeah, this is the portion that I need someone to share their multi-view. Yeah, stop share. So how, Nursidi?
Pak Franco,
Yeah.
for so our agenda with Tawada and PJPS, we will unboxing and check the tools tomorrow because
Okay.
our customer is still on duty for today. So maybe for today we can focus on using of software from
Uh,
your from Singapore. You can how to uh, how to use and a step how to use the software multi-view
okay.
uh,
I'll try because
only software.
yeah, because I'll try it now.
Okay,
We might not be able to do calibration and setup, okay, but I'll try to open my multi-view and check anything that we can do for today. Okay.
okay, no problem. Okay, no problem.
Okay. All right.
Okay.
So I'll share my screen again. Okay. So um, typically when you uh, plug in the equipment, okay, so first thing that you need to do is check your boot P icon, usually this one. Can you see my whole screen?
Yes.
Yeah, you can see this. Once you install the boot P, you can put a shortcut icon on your desktop so that you will know that the boot P is here. So make sure that the boot P red dot will turn to green first, okay, before opening your multi-view, okay? And then on your equipment itself, you must make sure that the LED for eddy current or ET is also on, okay? So once you're on and this one turns green, okay, if not, you can right click and then you check status, okay?
Okay.
So if you check status, usually there's no errors here,
Okay.
okay? If there's no error here, you just close and then go back to your, oops, sorry, go back to your boot P, you right click and then just press refresh,
Mm.
okay? So once you press refresh and then this turns to green, then you open your multi-view software. Don't open the multi-view software if this one's still red.
Okay.
Okay. If not, sometimes we have issue that it cannot communicate at all. You need to shut down everything again.
Mm.
Okay. So make sure this one is green and then yeah, you can turn on your multi-view. Okay. Oops. Wait, where is that? Okay.
And also the status of putih is run. Okay, Pak. That's right, Pak.
Yeah. Uh, okay. So yeah, let's go back to boot P. So checks, you can configure also if there's something wrong. So make sure this one also is all green. And then usually here, it will tell you ND to Olympus, and then it will show you this firmware here. So if you have the ET firmware is here. So make sure that it's communicating with the firmware. And then, yeah, as mentioned a while ago, if everything's okay, then you can just press OK, then open your multi-view, right? So once you're on the multi-view, oops, then this one should be green, not red, not yellow, okay, or amber. Okay, make sure this one is green and then you click this one. Oops, my multi-view is not. Yep. Okay. So this is the multi-view interface. Okay, so you have all this uh, interface here. So currently I'm now on the ECT interface. Okay, so these are all the shortcut tabs that you can use later on. Okay, so you can move all this if you want so that it will be saving some space. Okay, so these are the things that you usually see on the multi-view software. Okay, so you have here all the menu tabs. Okay, then you have all shortcut buttons here. Okay, and then on your specific setup for your ET channels, you can click here and then this one will come out. Okay, then you click again to go out. Okay, so um, so on this interface, you will see you have your strip chart of D90, strip chart of A90. You have your impedance plane. you have 4 impedance plane. Usually you have your D90 here, you have your D180, you have your mixed channel impedance plane, and then you have your A90 for big defects. Okay, so remember, for small defects, you should see between D90 and D180. Okay, so this is used for analyzing your flat bottom holes when you're doing calibration. Okay, for mixed channel, this is where you will see the if the defect is because of a support, or it's just a true indication. Okay, as I mentioned earlier, if there's an indication here, okay, and you see under mixed channel that it's just a small dot, or between here only, so that means that's a support. Okay, but when you see there's an indication here, indication of support, and you can see also there's an indication here, so that means there's a defect under the support. Okay, so this is quite useful when you're looking for defects that are near the support or under the support. Okay, then of course for absolute 90, this channel is used when you want to when you are analyzing big defects, or like corrosion or erosion. Okay, so first thing that you need to do when you want to do a inspection is to do a setup of your calibration, or setup using the calibration tube that you have. Okay, so what you do first is under setup, you'll see here wizard. Okay, you click on that, and then if you have a previous configuration, you will see this window. Okay, pop-up window. If you don't want to save the previous configuration, just press no. Okay, if you want, you just press yes. Okay, so now you will be under the new setup. Okay, so here the wizard will ask you what name of the setup that you want to put. Okay, so maybe we put first test. Oops, sorry, put Olympus. Okay, so description, maybe description of your, maybe if you have a lot of heat exchangers, you can put a brief description of what heat exchanger are you inspecting. Maybe heat exchanger 1, you can do it per location, like that, just a brief description. Okay, for the device, of course, is default MS5800, and then the technology, you can select it here. Okay, so if you're using ultrasound, you must select it before when you open the MS5800, I mean the multi-view, you will have two selections between iris and ECT, RFT, NFT, and MFL. So you use you click the ultrasound or iris. So for your application, you use eddy current. Okay. So maybe I just put that one. Okay. So once you're done here, you just press create. Okay. Then next you put the material. Okay. So under material, you select what material you have currently. Okay. So for example, this one I have Admiralty brass. If you don't have any material listed here, you can add here. Okay. You can create new, as long as you know the resistivity. Okay. So resistivity is microohms per centimeter. Okay. You must know the resistivity of your material. I mean of your new material, then you can include it here. Press new and then you include. Okay, if you don't have any of the material you're having now, if it's not included here, you can add that, as long as you know the resistivity value. Okay, next you must know the thickness. Okay, this one I'll select Admiralty brass, so automatically it will compute, it will show the resistivity. Now the thickness. Okay, if you don't know the thickness, but you have the BWG number. You select it here. So example, your BWG number is 16. Okay, so you just highlight that one and then press OK. And automatically it will show here. Okay, so for frequency 90, you don't have to worry about this because it will automatically compute for you. So the software will compute what is the best frequency 90 for your material with specific thickness. All right. Next, sorry, I have to answer a message first. Okay. Next would be your type. So usually we have two types of eddy current probes that we use in our inspection. We have the bobbin type, which is the most common one, and then we have the AC type, which is used for finned copper tubes. The one that is used for condensers or evaporators in air cons like that. So we use the AC type. Okay. For the common one, we use bobbin. Okay. For reference, this one is internal as default. Don't choose the external. This external is used for the old equipments. Okay. For now, we're using internal. Okay. And then connector. So we have 41 pin. This is used for the AC type probe. For bobbin, we only use 4 pin. Okay.
Pak Franco,
Yes.
for AC tube,
Uh-huh.
that you mean is flexible probe.
Sorry.
For AC type of probe,
Uh-huh.
for the example is flexible probe, right?
Yes.
For tubing that we have a bending in
No.
no.
The one is not the flexible one. I mean,
Oh,
sorry. I miss your question. This is not flexible one. So the flexible one is, if I'm not mistaken, TEG. Uh, so this one is actually it's a bobbin probe with an pancake coil probe. So it's a
oh,
combination. That's why it can detect circumferential crack on finned copper tubes.
oh, okay.
Okay. So this one, this AC type probe, it has two connectors. So one connects with the bobbin and one connector with the pancake coil. And then you need an adapter so that the adapter will plug into this 41 pin.
Okay, okay.
Okay. So
Thank
for
you.
your case, you have only bobbin type and then the connector is 4 pin. Okay. Next. So this portion of the setup, so it shows you all the channels that are used. So there's no need to change anything here. Just leave it as it is because as I mentioned a while ago, the equipment already has given you has computed, sorry, the frequency 90 that you'll be using. Okay. So if frequency 90 is 8, of course, times 2 is around 16. Okay. For here is 17. And then divide by 2 is 4. And then divide by 10 is 8.8. So this one, usually we don't change anything here. For the mix, we only use D90 and D90 over 2. If you have a setup that is better for you, you think it's better, then you can change it here if you want. Okay, but as default, we just keep this one. Okay, so no need to change anything here.
Okay, so it's automatic.
So next, so this one would be your calibration tube. Okay, so on your ASME calibration tube, you have this defects and support. So you have your hole, you have your flat bottom hole 80%, 60, 40, and then 20% flat bottom hole. Usually there are 4 as per standard. Okay. For your OD groove, you have 20, you have your ID groove of 10, and then you have the support plate. Okay. So as I mentioned a while ago, when you're using our calibration tube, you have 3 extra. defects. So you will include that one later. You cannot put those defects here. You will need to include that one later on the setup. Okay. So next, these are the different defects that you usually incorporate with your report. Okay. So you have your defect one, which is the obstruction. You have your dent. You have your plugged. You have your pit. You have your wall loss. And then on your support. Okay. So these are the typical things that you usually put on the defects. If you have additional defects that you want to put inside your um, report, you can do so here. And then you just mention which channel you usually see those things. Okay. Then just press next. And then here. Okay. So as per ASME standard, any hole, the angle should be 40 degrees. Okay. And an amplitude of 1 volt. Okay. So make sure that on the differential channel, your hole will give you a 40-degree angle and amplitude of 1 volt. Okay. Or close to 1 volt. Okay. So on absolute channel, so hole will still show you 40%, 40 degree and amplitude of 0.1. Okay. Before we use 1 volt also here, but absolute channel usually is quite big. So it saturates until up. So if it's saturated, then you will not get the whole picture of the defect. So usually they put it as 0.1 only because it's an absolute channel. Okay. So once all done here, you just press finish. So now just press finish, then it's configuring. Okay. So next that need to do is add the calibration point. Okay. So remember, we only have a few calibration points basing on the um, ASME standard. Okay. So now we need to add big hole, flat bottom. It's OD group 40%, and then OD group 60%. Okay. So to do that, you click here. So under setup, right? So make sure you're under setup. You choose analysis setup here. Okay, you double click that one, and then you'll see this window. Okay, so once you see this window, you'll see here calibration points. You click the tab, and then these are the defects that you usually see in an ASME calibration tube. Okay, so now you need to add 3 defects. Okay, so press add here. So first that you need to add is big hole. You type in big hole. You choose between in or out. Of course, obviously it's not in, it's not out, but just put out. And then how many in percentage is 100%. Okay, so it's 100%. So that's a big hole. Okay, so next, add again. So put OD groove 40% and click here out and then put 40. Okay, next, add again OD groove 60%, out, and then put here 60. Okay, so everything's done, then press OK here. All right, so when you go to your calibration, it should have additional 3. Okay, you have your big hole, OD groove, and 40. 40 and 60. Okay, so next that you need to do is under um, depth curves. Okay, so under depth curves, what you usually do is we add additional 2 more channels here for the depth curves. Okay. So to add 2 channels, we press add here. So we usually choose D180. Okay. So you have D180 here, you have D90, and then next that you need to add is, because you added 2 OD groups, right? 40% and 60%. So you need to add another channel, which is A90. Okay. But instead of face over depth, when it comes to curve type, you choose V over depth. Okay. And then what would be your extension? You just put voltage. Voltage over dash OD. Okay. So this will be your depth curve for external defects that are quite big. Okay, so this would be the defect 20% OD group, 40% OD group, and 60% OD group. Okay, so now you are done. Now we choose what defect are we going to detect on each defects on each channel. Okay, so you go here, A90. So remember a while ago during the earlier slides, when you are analyzing for big defects, you use A90. Okay. So hole is not a big defect. You unclick that one. Flat bottom holes also are not big defects. Unclick, 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 unclick. Okay. So your yep. Okay. So A90, your big defects are OD group 20%. Your ID group 10%. You have your big hole. You have your OD group 40 and then your OD group 60. Okay, so that would be A90 face over depth. Okay, next you go to A90 V over depth. So this one is only for OD grooves. Okay, so OD groove 20, OD groove 40, and OD groove 60. Okay, next for differential. Okay, so differential is the opposite of absolute. So you can only see smaller defects. Okay, so for differential 180, you need to check hole, all flat bottom holes. Okay, plus we have one more ID group. Okay, so why I included ID group when it's not a small defect? Unfortunately, we don't have any other ID defects, only one. Okay, if you have ID defect that is flat bottom hole, you can click that one. Okay, if we don't click the ID group, we cannot create a depth curve. Okay, so you must click the ID group 10%. All right, so go to differential 90. So it's the same as your D180. So you have your ID group, your flat bottom holes, and then remove the OD group here. Okay, then last one is your mixed channel. So same, this one is the same as D180 or D90. So you remove the OD group 20%. Okay, so once done, you press OK. So this is the part that you need to do a calibration. Unfortunately, yeah, I can do that now. So anyway, let's see, maybe there's let's see um, anything here, maybe have. Oh, sorry, should be under analysis. So it should be something like this. So once you do the calibration, right? I mean, uh, you do your scanning. So it should be something like this, but anyway, we'll just look at it. Okay. So I think the calibration, we will do it tomorrow if you have the equipment. Okay. So it's something like this. So once you scan your tube, okay, so you'll have this type of indications. So this will be show you each individual defect. Okay, so from here, once you have scanned, you can do a system calibration. Example, you have system calibration, and then you choose the defect based on the calibration tube, and then from from here, then you just click whatever defect that is, and then press record. Then you need to go through every indication. Okay, so to check each indication, so you okay, sorry, to shift, I mean to zoom in, okay, press shift. If you press shift, there's this icon magnifying. Okay, so if you put right click on your mouse, you can go previous zoom. So this was the previous zoom, right? So if you want to zoom this, you press shift and then go to the area that you want to zoom, start. Then you click your left click on your mouse, and then you drag down while you're still holding onto your mouse, and then you release. Okay, so now it's zoom. Okay, so you know that this one is your start and this would be your end, as stated on this demo. Okay, so to click on specific defect, okay, so you want to click on all the defects here, you just put your cursor before the defect, you left click on your mouse, and then you want to go to the end, you right click on your mouse. So this one will show here. Okay, so this is the all the defects it's shown here on your impedance plane. Okay, so if you want to see specific defect, okay, so here you left click, then you right click. Okay, left click here, then right click here. Okay, so make sure the gate is, I mean the defect is between the gates that you created, and then you click here, left click here, make sure that's on the MR or maximum rate. Okay, so once you click again, it's on the PP or peak to peak. Okay, so when you're doing analysis, it's always MR. Okay, and then your voltage, I mean your arrows on your strip chart always facing up. Your voltage, you can bring it down or bring it up by either clicking your mouse left and right. So if you click right click, it will go up, the voltage will go up. If you left click, the voltage will go down. Okay, so usually analysis part, some inspectors they use 2.5 volts, some can go up to 0.5. Okay, so depends on the inspector. Okay, so let's go for 1 volt. Okay, as I mentioned a while ago, so this one under MR, you can see that this is a ID defect. Okay, the voltage is too high. Remember, the voltage for whole is only one volt, sorry. But this one is 5 volts, 5.335 volts, 3.7. So this one is quite big. So you need to see on the absolute. Okay. So under absolute, it shows you it's 10% ID. Okay. So it's an ID defect. Okay. So next, you can drag down your mouse. Okay. So you go here and then you left click and then you can drag down. Okay. If not, you can left click here. All right. So here, so you see that it's also above 1 volt here. This one is 9 volts. This one is 11 volts. Okay. So this one is, you'll see here, it's, oops, sorry. Let's see, under volts. Okay. So because this one is too big, it went out to the impedance plate. So you can choose under here. Remember the channel that we added, V dash OD under voltage. So it shows you it's around 20%. Okay, so this is a 20% defect, OD groove 20%. All right. So next we need to check this defect. So let's see. Let's go back here at A90. Oops. We go here. Okay. So here, under this one, you see it's 1 volt, 1 volt. So that means this is a hole. All right. So you must check here 1 volt, and then this 0.1, basing on your ASME, 0.1 volt or 1 volt here on differential. That means this is a hole. And then you'll see the angle is 40. All right. Next, you can see here, this is also around approximately 1 volt. So you need to see it here, both, and then you'll see it's 81%. Here is 80%. So you go to the nearest one. Okay, so no, you know this one is an 80% OD groove. 80% flat bottom hole. Right. So next, same thing. This one indicates a 64% OD. All right, so you have at least around 1 volt, 1.2, 1.00. So this one is a 60% flat bottom hole. This one is around 40% flat bottom hole. Okay, so you have 0.8 volts here. Then this one would be your 20% flat bottom hole. All right. Then this will be your groove. Sorry, not groove. Support plate. Okay. So you can see here, we increase the volt. We decrease the volt. So you can see here, there's an indication, right? But when you go to the mixed channel, it's just a small dot. Okay, and there's no voltage value. Okay, so it's very minimal. That means this is a support. Okay, then next, we go to this. So this one, so it's high, and this one is saturated. So we can use the V over D, just around 20%. Again, okay. Then you can see also the voltage is around 1. So next, same thing. This is outside. Okay, so it's around 40%. Then this one would be around 60%. So you check your A90, 62. Okay. And then this one, most probably this one is a hole, big hole. Okay, so sorry, it's around 27.3. Okay, and voltage of 5 5 here, 3 here. So you'll need to go to absolute A90. And then it shows you 81% ID. So basing on our calibration, we don't have 81% ID. So this one is a hole, okay, or wall loss, okay. So if you would check the depth curves, oops, sorry, close this one first. So this is a common depth curves, okay. So for A90, he used big hole, OD groups, and then the ID group of 10. So you'll have this, okay. So usually depth curves are like this, okay, except for A90, this one, VOD. The depth curve for this one is just straight, okay. So you here, you'll see the 10% ID here. This is the angle. And then you have your big hole here, 100%. And then 60, 40, and then 20% OD group. Okay, so you'll have a depth curve here. For A90, since you're using only OD group, so you'll just see a graph like this. It's not a triangle because you didn't include the ID. You only use OD group. Okay, so you have your OD group at 20 here. It's approximately 1.33 degrees. I mean, in terms of volts, 1.33. This one is around 3.22 volts and then 7 volts. All right. And then D180. Okay, so D180, as I mentioned a while ago, you just use the smaller defects, okay, plus the ID group. Okay, so it will plot this curve. All right, and then for D90, you have this. So it's similar to D180. Okay, only thing is, the difference is that D180 has a greater separations of angles. Okay, for example, this one is also approximately 178. For D180, only around 121. So yeah, D180 have a better separation between defects. And then your mix, of course, you're just following the either D90 or D180. Okay, so when everything's okay with the equipment, then we will do it. We will do this one in more details. And I want one of you to, really do it using the multi-view. At least you have a hands-on experience on this one. Okay, so any questions so far with this?
Kalau ada
So
pertanyaan, Pak, dari tim PJBS.
Pak, tanya dikit, Pak.
Oke, silakan, Pak.
Kadang kita kan buat kalibrator kan ke bengkel itu kan kadang defeknya kan nggak sempurna ya, nggak sempurna di 60, di 40, di 20 gitu ya. Terus
Cacatnya itu.
Iya, cacatnya gitu.
Iya.
Terus kalau kita lihat dari alatnya ini kan langsung detek berapa persennya gitu, Pak ya.
Iya, betul.
Nah, nanti apa bisa diakali gitu, maksudnya gimana? Defeknya itu di kalibrasi itu nggak sempurna, kadang OD itu kebaca ID gitu Pak, titulnya itu Pak, karena ketekan dari tool buat cacatnya seperti itu, padahal di defeknya di kalibrator sebenarnya OD tapi kebaca titulnya di ID, gimana seperti itu Pak?
Oh begitu.
Yeah. Karena ketekan kan jadinya kalibratornya itu kan nggak sempurna Pak, berapa itu ketika dibor itu ketekan, jadi ada kayak tonjolan ke dalam gitu Pak, bacanya itu ide gitu.
Oke, Saya akan
Iya.
tanyakan ke Pak Franco. Pak Franco,
Yes.
from PJPS has a question about if we make some custom calibration.
Mm-hmm.
Usually we made OD groove. It's not good. So the calibration tube is bending inside, bend inside. So from the tools, when we calibrate it using tube, it's read by ED groove. How to do correct it?
Okay. So you mean to say that the specific group is not like 40, not 20, like
Yes,
that?
yes.
So you can do
So
that. You can still do that. You just need to, when you are doing the how to say this system calibration, right? Under analysis setup, calibration points, you can just choose the percentage here. Okay, so example,
mhm,
like you have OD group that is instead of 60, you put 80, right? Or maybe
okay.
instead of like flat bottom hole, because what we realize um, I mean, when customers do their own machining, right? It's not actually like 80%, 60%. Sometimes it's around 85, or maybe there's a miss machining. Instead of 60, become 55. You can change the value here.
Mm,
You can change the value here. Okay. So when you go for calibration, I cancel now. When you go for calibration, so of course the value here is different already, right? As long as you know where's the location of those defects. So you calibrate it, and then automatically it will just show you specific. As long as you know, as long as you go to the standard that 40%, 40-degree defect, 40-degree angle is a hole. So because of ASME, you only need actually 3 defects. Okay, you only need a hole. You only need a 3 defects plus support. So you only need ID groove, you only need OD groove, and then you need a hole to create depth curve. That's why when you go to depth curves, this is quite important. So you must have an ID groove, you must have a um, hole, and then you must have a OD groove or OD defect. So that's why, yeah, it doesn't matter whether it's, you know, it's not 60, it's not 40%. These are additionals only. So
oh,
you
so
just need
so
to, sorry.
so the important ones is only the ID groove, OD groove, and 100% Wallace.
That is when you need to do depth curves here.
Okay.
Okay,
Oh,
because ASME already stated when you are working on a tube, right, you must follow this ASME standards. Okay, by right you must follow these standards, but as what I mentioned, sometimes you cannot really create an 80% flat bottom hole unless if you go for a very good machinist.
yes.
Because, yeah, because sometimes 80 is not really, I mean, they cannot really give you 80%. Even if you go calibration, and if you want to calibrate your calibration tubes, sometimes the hole is not 80%, sometimes not 60%. So you can adjust that one. Okay. The important thing is when you are following the ASME standard, you must have all of these specific defects. So
Okay.
you can add additional ones. So as long as you have these ones, and then you can add more. Okay, but when you want to create depth curve, you must have the ID group, you must have the hole, and you must have OD defects. That's all.
Oke. Jadi begitu Pak. Apakah sudah menjelaskan? Jadi tidak masalah untuk apa namanya, misalkan dalam machining custom calibration itu, misalkan tidak bisa sesuai aktual 80% pun tidak masalah, kita bisa ubah sistem kalibrasinya, diubah ke misalkan 85% yang kita uji, kita bisa ubah ke 85, maupun juga ketika dengan cacat yang lain. Dan juga yang paling utama yaitu yang dari depth curve itu sendiri. Yang penting kita sudah mendapatkan tadi big hole, kemudian ID group, dan juga OD group dengan depth curve yang sudah standar seperti ini. Begitu, Pak.
Berarti presentasinya bisa dirubah sendiri ya, Pak ya?
Betul, betul, bisa diubah. The presentation of ID and OD can adjust correctly.
Terus saya tangkap tadi minimal ada 3 cacat, 1 ID, hole sama OD sudah cukup bisa untuk kalibrasi, betul ya Pak?
Betul. Memang yang utama deep curve-nya ini bentuknya seperti yang di layar.
Bisa bentuk curve kalibrasi ini Pak ya?
Betul.
Iya Pak. Ya, di copy Pak, makasih.
Siap. Terima kasih, Pak. Oke, Pak Franco, we can continue.
Okay, so yeah, so now most probably we'll just create a file. Okay, I'll just show you how to create a file on multi-view, and then create the tube list. Okay, so once you want to create a file, you can go to under inspection here. Sorry, operation. Okay, so just make sure that you're still under setup, and then you go here, operation, and then under operation you go inspection. Okay, so here you can create a folder. Okay, and then you can browse that one. Okay, you can create specific folder that you have created for specific tube inspection. Okay, so maybe I'll do that one today. Oops, I cancel this one first. So I create folder. So Olympus tube. Okay, so let's go back. So make sure you're under setup tab, cooperation, inspection, and then browse here. So you go to the folder that you created. Okay, and then press OK. So now you're under the folder. Next, so inspection list. So since you don't have inspection list first, as of now, you can browse again, and then you go to the you go to the folder that you created just now. Okay, and then you create a file name of your inspection list. Okay, so I put all the. Okay, so this file name is your list or your tube list. Okay, so I open. Okay, so this would be your tube list. And then, of course, every tube list, when you finalize your analysis, you need to create a report file. Okay, so you go back to the, you click on the folder that you created. Okay, so under here, you create your report file. Okay, so maybe I'll just put Oli again. Okay, so first you need to establish a folder where you want to save all of your inspection details. Then you create a tube list, okay, where you will create your tube numbers in terms of rows and columns. And then lastly, you need to create a file name under your, report file So every time you finish your analysis, you can create a report and then it will automatically save on this report file. Okay. So once done, you press OK. And then you go to your inspect tab. Okay. So once you press the inspect tab, you already go to that particular folder. Okay. So what you do now is you add the numbers of rows or columns that is dedicated to your inspection area, or whichever you're inspecting in terms of numbers of columns and numbers of rows. Okay, so for this one, we usually start with row. Okay, so row is the horizontal part of your heat exchanger. Okay, so I'll whiteboard. Okay, for example, oops. There is this one first. Okay, so for a tube, sorry for my drawing, yeah, maaf ya. Okay, so
No
example
problem,
your
Pak.
example your tubes are like this, right? So you have your row, then you have your column. Okay, so sometimes tubes are staggered. Okay, like this. Okay, so the column here on example, this one is your row 1. This one is your row 2. Okay, so this one is your C1. This is also your C2, C3, C4 column. Okay, so for R1, your column would be different, right? But this one is R1, C1, C1, R1. Okay, but when you see the alignment, actually it's not aligned with R2, C1, but it's okay. You don't need to worry about this one, because as long as you know that this one is R1, C1, R1, C2, R1, C3, R1, C4, even though they are not aligned, it's still okay. Because the important thing is at least you know which row are you inspecting and what number of column. Okay. So example here, we go back here. Okay. So at first row, we have 1, 2, 3, 4, 5, 6. Okay. Second row, 1, 2, 3, 4, 5, 6, 7. Okay. So we add here. Row 1. Okay. So usually row 0, 0, and then column 1. Sometimes inspector use this one to do their calibration tube. Okay. So before they inspect the whole, the tubes on the site, they use one. They use this as for to check the calibration tube. Okay, so usually they use at very first tube number or the very last tube number. Okay, so remember, you can also put like 0, 0 if you want. So this one represents the calibration tube. Okay, so next, so remember our row 1 has 6 columns, right? So you can change this, double click, change 1. Okay, and then you just add. Okay, so 6 columns in row number 1. Okay, so you have 6. Okay, next, so row number 2, so it's already here 2. This one you change to 1 again. Okay, go here, and then you have 7. 6, 7. Okay, and then you just continue depending on the numbers of rows and columns that you have. Okay, so this is quite important when you are using the multi-view as your as the software that you need to put on your list. You must make sure that the numbers are tallied with the number of the tubes that you're inspecting. Okay, this is quite different when you're using Carto or Tube Pro. Okay, for Tube Pro and Carto, you can create your tube map and then you can transfer over here. So once you transfer over here, this one will automatically be filled with the columns and rows of tubes that you are inspecting. Okay, if you don't have Carto and Tube Pro, so um, you need to do this one by one. Okay. By the way, just an update. Olympus no longer support. I mean, Tube Pro is no longer being sold by Olympus. Okay, so we only sell Carto software for tube mapping. Okay, so after doing so, then you start your inspection. Okay, so to start your inspection, you just go to the first. You see here that there is this 2 dash, right? 2 dash. When you click here, then this one will start. Will pop up. Okay, you either want to show this or not, just minimizing here. Okay, so once you go to your first tube, so for this one, you will designate it as your calibration tube. Okay, so you just press start and then you just end if finished. Okay, and then automatically it will go to the next tube. Okay, so once you're done, this one will become like, if I'm not mistaken, asterisk. So it will represent that this one's already been inspected. Okay, so if not inspected, you have this 2 dash here. If inspected already, it will change the icon. Okay, so you'll just go until the very end. Okay, so unfortunately we cannot do that one now because I don't have the equipment. Anyway, yeah, if you have already done everything, okay, now you can analyze one by one. Okay, so see if you've done everything here, once you press analysis, those files will be here. I mean, those data will be here, and then you select one by one. Once you select one by one, then you analyze just like what I do before. Okay, so you just click like that. You just see which one is, I mean, which is one, which area have the defect, like that. Then you just analyze. Okay, so for typical inspection of tube, we only usually, I mean, inspectors usually only show which one is the worst defect. Example, like this is your first tube, and then you only see hole. Okay, you see a lot of defects here, but the worst one is still hole, right? So you go to the hole and then you just put hole, and then yeah, that's all. Okay, so some clients want specific, like even though there's a lot of defect, you must show them the defects. So it depends on the client that is asking you to do the inspection. But generally, inspector just select which one is the worst one, and then that's the one that it's written on the report. Okay. So yeah, so after clicking everything, and then you can see here, there's a report here. Oops. So report. Okay. So this is the one that you can um, uh, share to the customer or print. Okay. So you can put info. So you can put the client. You can put the site, what exchanger it is, what section outage, like that, and then additional comments. Like um, additional comment is just like a summary of the defect that you saw. Like multiple defects seen in different locations like that, and then find report for details. Okay, so once you press OK, then it goes back to the report. So once you export the one, then you'll have a like um, like a file that shows you everything. Okay, I think I have one here. Let me open my report. Maybe I'll check first. Maybe. So far, any questions?
Apakah ada pertanyaan, Pak, dari tim PJBS? Pak Franco?
Yes.
I have a question. When we use a balancing button, we insert the probe on the tube, or
Sorry,
when we use a balancing button.
Balancing.
Yeah.
Yes. This one is quite tricky because balancing should be done actually on the part, right? But you must make sure that you balance it on a surface that there's no defect.
Okay. We always do on every tube, or only?
Not necessary.
Oh, not necessary.
Yeah.
Okay.
You must make sure that, because sometimes when you're doing inspection of heat exchangers, sometimes the tube that are inserted is not homogeneous. I mean, because it's supplied by different supplier, right?
Okay.
Sometimes the material, the alloying percentage is different. So yeah, I mean, once in a while it's good also to balance it, but just make sure to balance it on a defect-free area. If not, yeah, you might have errors on your analysis.
So the best place to balancing is on the calibration tool. That's right.
Calibration and the tube itself.
Okay.
Yeah, I'm looking for my tube data. It's missing. I'll get my, what's that? I'll get first my thumb drive. Wait. Okay, so I'm sharing one of the file that I created with my intern. So we have this. So this is a file that was created after doing servicing on one of the customer's equipment. Okay, so I created, if I'm not mistaken, 300 tubes for this. So on the folder after analysis, right? So you have data. Okay, so this is the data, and then AN is the analyzed file. Okay, and then After that, so you have the analysis. So similar to this one. Okay, so this is the analysis report. Sorry. So it shows you which row and column of the tube. Okay, if there's no defect, so you put NDD, no defect detected. And then if you saw a defect, then based on the
Sorry, Pak Franco. The
yeah,
screen share screen is not
not yet. Sorry.
not yet shared.
New share. Yeah. Oops, sorry. So this is the one. Wait, let's go back. Yeah. Close this one first. Okay. So this is the folder that I've created when we are doing servicing for one customer. We created I think 300 data for this specific customer. So if that DAT, that means it's the data is acquired, AN is analyzed. Okay. So after that, you will be having analysis report. Okay, so this would be under, oops, sorry, under PDF file. So this would be analysis report. Okay, so you will see here row 1, column 1. If there's no defect, then you put NDD. So the NDD is somewhere, yeah, here. So if you analyze and then there's no defects at all, you put here. You click this one and automatically this one would be NDD. Okay, so like this. Okay, so if you have the defect, you will just see which channel are you looking at. Okay, and then it will show you the position and then the length of that defect. Okay, so these are based on our calibration tubes only. Okay, so this would be your PDF report. Okay, so if you're using Carto software, you will be having additional like drawings. So it will show you the front face of the heat exchanger, and then it will show you the color. I mean the defect area, defective tubes, and some colors. So the color will represent the severity of the defect. Okay. So in this report also, aside from having PDF, you will have this like Excel sheet. So you click this one. So these are the typical defects. Okay, so these are all the tubes. See, 303 tubes. So these are the defects. Okay, with this one is more comprehensive. You have the volts, you have the degree. Okay, and then where you saw the defects. Okay, and then yeah, then part would be the details of the inspector. Okay, so any questions so far?
Apakah
So
ada pertanyaan, Pak?
Pak Franco,
yes,
for the setting MFL, RFT, and
NFT.
NFT, the style is same as what you saw us early?
No, it's kind of different. You mean the setup?
Yeah. Yes.
Yeah, okay. So for setup, like example, let's go back to, oops, what's this? Let's go back here to multi-view. Oops. Okay, I close this one first. Okay, so let's go back here. So remember under setup, right? When you go wizard, so you go again here, only two. So next would be, let's say, remote field RF, which is quite common also nowadays. Okay, create. So for RF, the difference is the calibration itself, the defects that you want to calibrate, and then on the interface is using strip chart and voltage plane. Okay, so I'll just create one to show you. Okay, so similarly, of course, your wizard will ask you the material, and then this one is thickness. Okay, and then of course the type that you want to, what type of RFT you want to use, either single exciter, dual exciter, or dual pickup. Okay, and then preamplifier gain, this is the gain that is written on your probe. So remember the RFT probes, you have this like preamp gain in the near the serial number of your probe. So you'll just key in this one, usually around 30 or 40 dB. Okay, then just press next. So this one, as of now, it will just tell you what is the optimum frequency. Okay, but later on you need to change this one depending on the separation of your defects. Okay, so far we don't change anything here. Okay, so we just leave it as it is. Okay, so you can also here mix channel, you can set this one if you want. Okay, and then with this setup, you can do you can choose your bandwidth. Okay, so your bandwidth is depending on which location you are. So there's this bandwidth range that you need to choose when you are in different countries. Okay, that one is inside the Tube Testing Help Center. It's a software that is included in your multi-view. So once you have that one, then you can see the bandwidth location. But for now, we just leave it as 20 Hertz. Okay. Sorry. I need to select this one. Okay, select this and then set this one and then next. Okay, so this is where it will be depending on what calibration tube you have. Okay, so for my side, I only have short 60 and short 40. This is OD group. Okay, so I'll click only this one, these two. So 20 I don't have, so I will not click that one. I only select these two. Okay, I don't have calibration tube that has long defects also, so I will not tick this one. Okay, lastly, for pit, I only have 80 and 60%. Okay, I don't have 40, I don't have 20. Okay, so this, remember, this is for RFT calibration tube, not the ECT, so it's different. Okay, so once I already established what defects I have on my calibration tubes, then I press next. Okay, and then these are the defects that you usually see on your inspection. So you have your wall loss short. Okay, so the extension is S. You have wall loss long, L, and then you have your wall loss tapered. Okay, So the extension is T. Okay, so you select all this, press next, and then for the standard of RFT, so the angle for hole is 90 degrees and amplitude of 1 volt. Okay, so for ECT, remember the angle is 40 degrees. Okay, and then the amplitude is 1 volt. So for RFT, it should be 90, and then the hole is 90 degrees. Okay, then just press finish. So here, the recommended measurement method for RFT technique is peak to peak. Okay, so for ECT is maximum rate. Okay, MR, but for RFT is peak to peak. Okay, so just press yes. Do you want to use the recommended settings? Just press yes. So it will automatically change your configuration. Okay, so you have 4 strip charts. Okay, and then you have 2 voltage plane. So the difference is that for ECT, you're using impedance plane. For RFT, you're using voltage plane. Okay, remember, it's measuring also voltage. So depending on uh, which area and what is the extent of your defect. Okay, so for absolute is checking your big defects like what do you call that, wall loss. Okay, so you need to check it here. For this one, for mix, you must sorry, not mix, should be differential. Differential 2, differential 1. Yeah, differential, let's say differential 1. Okay, so for differential, you'll be checking holes or small defects. Okay, and this one will be your strip chart. So that's the only difference. Okay, so first thing that you need to do is establish your support signal and then your wall loss here. Okay, so usually you have like if you would to see, wait, let's go for analysis. Oops. I forget where is it located already. Okay, so this one is, let's see, nope. So it's like this. So this is a wall loss. So wall loss peak to peak is around 60% short. Okay, so let's go here. Okay, so this one is 40%. This one is 60. Okay, so usually what we do is we see first like this. Okay, so once before calibration, we scan first the tube and must see what's the difference between 2 defects. Okay, so you see here. So this one is for, sorry, this side is for 60% wall loss, and then this side is 40% wall loss. So when you combine these two, you have a V shape, right? So you must make sure that the difference between these two angles is 20 degrees. Okay, so you go back to your 60. So the angle is around 70 degrees, right? You go here. So now it's around 94. So 94 minus 70 is around 24. Okay, so should be 15 to 20 20% difference. Sorry, 15 to 20 degrees difference. Okay, so you want to change that, you go to your MS5800 here. Oh, sorry, you go to ET channels here, and then you change your frequency here. Okay, so if the angle is too wide, you lower down your frequency, maybe make it 0.18. Okay, if the frequency, if the angle between two defects is too shallow or too narrow, maybe less than 15 degrees, then you increase the frequency. Okay, then you run it again. Okay, so once you run it again, make sure that the difference is 20. Okay, and then just make sure that you also need the support. Okay, so that's the support here. Okay, so it's quite hard to like explain now without the equipment, or without the um, equipment and the probes, but this is how we usually calibrate. Okay, so first is you change first the frequency so that this separation is around 20 degrees. Okay, so once you do that, you must also rotate your support. Okay, you must rotate to a point that this, because this is the indication of your thickness. Okay, so I mean, not thickness, but this is the indication that you have a support. So the support, if you'll see indication that it goes back to your 0, that means there's no flow of magnetic field. That means there's a support blocking that magnetic field. So it will go back to 0 and then go back again to the standard thickness of the material. Okay, so to explain further, sorry, to explain further why we have this like um, why we have like this 348 degrees, that means yeah, maybe I try to open again, sorry. Okay, so this will show you that you have a 350 degrees of wall loss, because you see this one, this curves. So this represents degrees of wall loss. So this one is 360 degrees. That means all around the tube you have wall loss. This one is 270 degrees, or 3/4 of your OD have defect. This is 180 degrees, or 1/2 of your OD have wall loss. And then lastly is this one, 90 degrees. That means only 1/4 of your OD have wall loss. Okay, so for this one, usually our calibration tubes have OD defect that is 360 degrees. So it will show you here around 353 or 360 degrees separation, I mean wall loss. And then it's a 60% short. Okay, so this is how we usually calibrate. Okay, so when it comes to pitting, it's kind of different. So we don't use absolute strip chart to do the pitting, I mean to analyze the pitting, but we do differential. Okay, so just make sure you lower down your voltage, and then you'll see it here on the differential. Okay, So this one, approximately 21%. Sorry. This one is 34 or around 40. This one is around 60%, flat bottom hole. This one is around 80%. And then remember the wizard setup, your hole should be 90 degrees. So this one is around 91. Okay. So this is how we calibrate things. And then after calibrating, then yeah, we can start our inspection. Okay. So for NFT, it's quite, for NFT, you only can detect ID group. So let's see NFT volting here. Calibration. Okay. So NFT is just like the interface is just like your RFT. Okay. So only difference is that NFT, they can only detect ID group, ID defects. Okay, so you can see here, peak to peak 57. So this is quite big. See, six volts. So it's a wall loss. Okay, and then there's a defect here. It's too minimal. So you go to your differential channel. So it doesn't show anything here. This one should be whole. It's around 90. It doesn't show here. So this one is whole. And then this one, you see, is quite big. So around 45%. Okay. So you see here, it's 20 volts already. But if you go down to 5 volts or 2.5, it's saturated. So you cannot see anything. So you just go back to maybe 20 volts. Okay. And then for MFL, to be honest, MFL I haven't done yet. But yeah, this is the usual interface for MFL. So you can see here wall loss. $15, then 40, and then this one is around 60. This one is around 80. Okay, so you're going to this one, absolute. Okay, and then for differential, you see this. Okay, so 40, 60. So just look at here. It's around 80. It's around 100. Okay, then this one, I think near the end. Okay, so yeah, RFT and NFT, the interface is the same, but for MFL it's kind of different. Okay, so as I mentioned a while ago, I'm not really familiar with MFL. I have not done any training for MFL yet. So far, I did only ECT, RFT, NFT, and IRIS. Okay, so last one is IRIS. Okay, so we go IRIS calibration. So for IRIS, it's usually like this. Okay, so you have this window here for your UT settings. Okay, Okay, and then you can toggle with this one. Oops, sorry. Okay, toggle with this, and then you see the difference between. So this one will be on this thickness. So this one will be your like your B scan here. Okay, so this one is for your B scan. Okay, and then this one will be on your front view, or usually D scan. Okay, so if you want to measure one example like this, so you just drag. Oh, sorry. Okay, to zoom in. Okay, so automatically it will have this magnifying glass, magnifying icon. Then you left click and then you drag. Okay, and then you have like that. So next, this. Oops, sorry. So you can use this if you want. Okay, you can also add view, cylindrical view, so you know where's the location of that in terms of when you're when you are starting with your target pin here. So this is the location of the defects. Okay, so you can use this. I think better we zoom out first. Okay, so you have 4, right? 4 defects here. You have 1. Maybe we can increase this one. Okay, so we have 1 here. There's another 1 here, here, and here. Okay, so you can choose which one you want to measure first. You want this. Okay, then we. Okay. So it depends on where you want to zoom. You can do that also. Oops. Okay, so from here you can measure your most minimum if you want. So you see here, this one is your automatic measurement. It shows you 2.14, but you can also adjust if you want. If you want to check really what's the minimum thickness, so you can check it here. So this one would be your manual entry. Okay, so your manual entry will show you the wall thickness and then your wall loss in terms of percentage. Okay, so yeah, so this is usually the thing that you usually do. Okay, then you can also do it here if you want. So same thing. This one will be your automatic measurement recognition, and then you can just adjust. So until it shows you how many percentage of the wall loss. Okay, and then you can see also here, it will change accordingly. Okay, so this is your minimal thickness. So there's no thinning here. Then you can go here. There's 4 thinning here. Then you just go through again. Then yeah, there's another thinning here. Okay. So yeah, so that's on the iris side. Okay. So any questions so far?
Apakah ada pertanyaan Pak dari tim BCBS? Untuk penjelasan dari software apakah sudah cukup Bapak-Bapak sekalian?
Anyway, for now, if you don't have questions, it's okay because we haven't handled the equipment yet. I think later on when you are doing your equipment, then I think there will be more questions later on. Okay. So, I mean, for now, it's just an introduction. So at least you know what will you expect when you will be doing your, I mean, when you're using your MS5800. So yeah, first thing that we need to do is make sure that your equipment is set for maybe tomorrow or Nursidi, you want continue training tomorrow or we make sure everything is set up first before we reschedule?
Okay.
Because tomorrow I have an afternoon meeting online with Malaysian customer also. So I'm not sure. You want maybe morning we do a setup first. We see everything's okay, and then we can reschedule the training maybe on a later day.
Okay, Pak. Uh, for tomorrow, we have agenda to unboxing and installation for the device.
Yeah.
And our schedule is go inside to the office of PTPGPS and also trial the unit.
Yes,
But if
correct.
you have you can arrange doing a meeting online for tomorrow. It will be good.
Okay.
But
Be
also
because my meeting with
uh,
Malaysian customer is
yes,
around 2 p.m.
okay,
So
okay.
around
So
1
I think
p.m. there. Uh,
okay,
but I don't know until how long. But usually my meeting is around 1 hour. So maybe in the morning
okay,
I can go online with you guys and and yeah, maybe during the setup maybe you have a question, then yeah, at least I can answer right away.
okay. We will try to arrange the meeting for tomorrow in the
Yeah.
morning. And bagaimana Pak Soleh dan tim dari PJBS? Apakah bisa dilanjutkan untuk training operasionalnya sekaligus trial alat besok pagi, Pak?